So let's look at another molecule. This time, let's draw the Lewis structure for carbon tetrachloride, CCl4. So again, our first step should be to count the number of valence electrons. So we have two different types of elements here. We have carbon, which is in group 4 of the periodic table, so it has 4 valence electrons. And we have chlorine, which is in group 7, so it has 7 valence electrons. But we have 4 chlorines, so we have to multiply that by 4. So we have a total of 32 valence electrons to work with. All right, so how are we going to arrange these atoms? This time we have 5 atoms. So remember, one of our rules that we talked about is that the first atom usually goes in the center of the molecule. So that's going to be carbon. And then we put the chlorines all bonded, not to each other, but to the carbon that's in the middle. So we're going to connect the chlorines to the carbon. All right, so now we need to glue them on. So we're going to add our pairs of electrons to glue each chlorine to the carbon. And we notice that that took 8 so far to do. We have a total of 32, so we're going to start adding more lone pairs. And we always start on the outer atoms. So we call carbon the central atom, chlorine the outer atoms. So we've used 8, here's 10, 12, 14. So that finishes off that chlorine, so we move on to the next. 16, 18, 20, 22, 24, 26, 28, 30, 32. So we've used our 32 valence electrons, and what we see is we were able, in doing this, to give each atom an octet. So remember, we have some shared electrons and some lone pair electrons. If we had 5 atoms and we each had to give 8 to them separately, it would take 40 electrons, right? 8 times 5 is 40. But because we're doing some sharing, we can get away with fewer electrons, and those are our bonding electrons. Okay, so this looks good. What we're just going to do now is convert all of our bonding electrons to lines to emphasize what's being glued together. So we have our carbon in the middle, the 4 chlorine atoms bonded to it. And then we do want to show all of the lone pairs still as dots. So we'll fill those in. So here's our structure for carbon tetrachloride. We're showing what are called single bonds. We'll get to double bonds in a minute. And this sort of shows why something like carbon would want to bond to 4 atoms, because in doing so, if it makes 4 single bonds, that's how it's able to get its octet. Okay, so let's move on to a new molecule. Let's look at ammonia, NH3. Okay, so again, first thing we want to do is count valence electrons. Nitrogen has 5. Hydrogens have 1, but there are 3 hydrogens. So that gives us a total of 8 valence electrons. How are we going to arrange them together? Nitrogen is first in the formula, so we'll put it in the middle. And we're going to put the hydrogens around the nitrogen. It doesn't really matter where you put them at this point, just sort of next to the nitrogen. Now we need to glue those hydrogens on. We need to stick them on with a pair of electrons. Okay, so that took so far 6. We only get 2 more because we have 8, remember. So where are we going to put these? Normally we start by putting extra electrons on the outer atoms, but here's something special. So hydrogen, because it's in the first row of the periodic table, it gets a noble gas configuration, not with 8, but with only 2. So hydrogen is always going to be an outer atom. It's always going to make just one bond, and then it's done. It doesn't have any lone pairs on it. Okay, so we still have 2 electrons to work with. We don't want to put them on the hydrogens. We'll go ahead and put them on the nitrogen. So we'll put it there. And luckily that helps us because that then gives our nitrogen an octet. So that fills up the noble gas configuration for nitrogen. So this looks good. Again, now we're just going to go ahead and replace all of the bonding electrons with lines to clean up our structure a little bit and show that lone pair on the nitrogen.